Good afternoon, everyone, and welcome to today's ABC-sponsored webinar, Creating Efficiencies Through Measurement in Renewable Natural Gas Production. My name is Caroline Skeet. I'll be facilitating this webinar. And before we begin, I want to give a big thank you to Vicelet and the team. Justin here is our speaker, but we're working with the rest of the team. Thank you so much for sponsoring. It helps support ABC and our programs, so we appreciate that. Just before we get started, I'm going to go over a little bit of housekeeping here. You should be able to see my screen called Quick Notes. You should also be able to hear me. If at any point during the webinar your sound quality gets bad, you can adjust in the audio pod of the GoToWebinar toolbar, which is probably on the right side of your screen. Also on the right side of your screen in that toolbar is the questions pod. You can ask questions at any time during the webinar. We will be handling them at the end of our content, but ask as soon as they come to mind, and we'll handle them then. We are also recording this webinar. You'll get the slides. Well, actually, today we have the slides in our handout, along with some other my follow handouts in the GoToWebinar toolbar there. Hopefully you see that, so you can pull them up anytime you want. But we'll also be sending out slides and the recording later this week to everyone who's registered. I'm going to kick things off now and hand them to Patrick Circus, Executive Director of the American Biogas Council, who is our moderator for today's webinar. So Patrick, please take it away.
Awesome. Thank you so much, Caroline. And thank you, Justin, the whole Vicelet team for engaging with us. It's been great to have you as a part of the American Biogas Council for so long. And for those of you who don't know about the American Biogas Council, we are the voice of the biogas industry in the US. We're pretty proud of the diversity of members and the couple hundred members that we do have that really reflect the growing industry that we are helping to continue to grow. Caroline, next slide. So this is where we are with the biogas market today. For those of you who attended our last webinar, I think it was last week, these numbers are actually even updated since then. So these are hot off the presses. Our great data analysis manager, Ian, had found some additional data and been talking with some folks. And there's a little over, we just crested the 2,400 operational projects in the US. And that RNG number is actually even higher now too. I missed that one. So we've got 304 RNG projects, not even counting the food waste ones. We're still trying to get our arms around some of the food waste projects. So that's really where we're going to be focused today, is on those RNG projects that are existing, or any of the potential 15,000 new projects that could be developed as RNG projects, because the important thing for today is what is in your gas? What's the methane content? What's the CO2 content? What's the moisture content? These are obviously important things to know as you're operating your biogas system and trying to sell a marketable gas to other people. So that's where Vicelet comes in. Caroline, if you go to the next slide, I think it's probably just us. Oh man, okay, you get double vision now with our cameras on. So Justin has been with Vicelet for almost a decade. He's in charge of business development and sales for everything related to biogas that you might be concerned about. So Justin's your person to come to if you're interested in any equipment. I think it's a great company to work with, and I think it's cool that they really own the fact that they don't do everything for measurement under the sun. They are really good at what they do, which is measuring methane and CO2 and moisture content, and doing that in a way that can hopefully lower your CapEx and your OpEx for your project. So simplifying your gas measurement, getting more efficient. That's what today's all about, all related to RNG and gas measurement and figuring out what's in your gas. So Justin, I'm gonna turn it over to you at this point and let you take it away. And just an extra encouragement, put your questions in as you have them, and we will take those at the end and expect to have a lively Q&A session. Justin, thanks.
Yeah, thank you very much, Patrick. Much appreciated. Hello and welcome everyone to our presentation on measurements for RNG production. As you said, my name is Justin Walsh. I work in business development for Vicelet's biogas, RNG, and carbon capture instruments. I come from a background in environmental engineering and working with various electrochemical measurement technologies. But today we'll be discussing how certain measurements in biogas and RNG application can create process and operational efficiencies, as well as what Vaisala and our measurement instruments have to offer. Just to reiterate again, question and answer will be at the end of the presentation, so please submit questions during the presentation. That way we can get to them in a more efficient way towards the end. And anything I'm not able to answer, will follow up by email afterwards, so have no fear there. And you'll be receiving an email link with the recording and presentation. I encourage you to share it, and please reach out to us or me for more information. Next, please. I'll begin with an overview of how certain areas in the biogas production and upgrading process benefit from monitoring. I would guess that most of you here are familiar with these, but there are still plenty of systems out there with very basic and minimal measurement and controls. I'll then highlight some of the challenges that make monitoring difficult and expensive, touching on some of the complexities involved with current monitoring systems. Then I'll look at some of the areas where humidity measurement would benefit operations and process control. I'll show how Vaisala's instruments can deliver that information, as well as other primary measurements, which can contribute to lower operational costs. Next. But first, I'd like to introduce Vaisala for those of you less familiar with us. Vaisala began over 85 years ago with the development of technology for meteorological observations. But then in 1973, we invented the first capacitive polymer sensor for humidity measurement, which has become the industry standard. Our sensors are used by prominent institutions both around and beyond our world, as NASA chose them for the Curiosity and Perseverance rovers to find water on Mars. Our diverse sensor technologies have allowed us to serve a wide variety of industrial applications, and our various measuring and monitoring solutions developed for process control help ensure product quality, energy efficiency, and personal safety. With extensive investment in research and development, we create unique technologies for humidity and gas detection so our customers can succeed in their business operations. Next. So now that that's out of the way, we can talk about how there are many reasons to measure the gas concentrations during production, from control to reporting. And I'm sure you've all heard the old saying that you can't control what you cannot measure. But there are externalities to that as well. And energy use is a common denominator that can affect operational expenditures and your overall carbon footprint. Next. You'll see here a perhaps oversimplified overview of the biogas production and use or upgrading ecosystem that we put together. Highlighted are some of the key measurement locations for monitoring the methane and carbon dioxide concentrations. I'll be focusing on the digester itself, the pretreatment phases, namely the water removal and filtration, the CHP, combined heat and power engine, and the upgrading intake and off-gas locations. Besides the product gas measurement that takes place before transport or grid injection, these are what we see as some of the more influential areas. But not all plants require measurement at all of these locations. Next, please. Being the two main gas products of anaerobic digestion, the methane and carbon dioxide ratio is a direct indication of the health of that biological process. That knowledge has a clear benefit to control feedstock additions, mixing, or any additives used to aid in digestion. This ratio can also inform how much heat is required to maintain a healthy digestion environment. And that info can be fed into the controller to save energy when managing that environment. This can be more impactful in colder climates, especially if waste heat is being used for multiple purposes. Measuring at each digester adds insight as well, as they are independent living organisms that are going to behave differently. So if you're only measuring after they're combined, you won't have a clear real-time picture should something be going wrong with one of them. Continuous real-time monitoring the outputs allows operators to react more quickly to changing conditions and to reduce risk. Next, please. This one is fairly intuitive as well, since you need to know the gas quality before sending it to the upgrader. The methane concentration, along with the pressure and flow rate, will determine the potential volume output that you can expect, allowing for adjustments to the system to ensure efficiency and uptime. This can also help predict the tail gas volume, and I'll touch more on that measurement as well. If the gas is found to be of low quality, it can be diverted to different uses, such as feeding the boiler, the CHP engine, or sent to the flare in the worst case scenario. Because fouling of the upgrader can lead to shutdowns, which is equal to lost production, protecting this capital equipment with measurement is a clear benefit. Next, please. Now I'm highlighting the most popular upgrading methods here. And in the market, we see that membrane separation has the widest adoption, followed by water and various chemical washing, amines in particular. Also common, but a little less so, are the pressure swing absorption methods. Each have their advantages and disadvantages, which come in the form of the quality of the gas that they can accept, capital costs, how much energy they require, and how much methane is left in the off gas, known as the methane slip. Membrane technologies, which I'll get into a bit more, benefits from continuous measurement on the inlet for protection, for recirculation between stages, but just as much for the off gas. Monitoring the methane slip can be an indicator for control and performance, as well as an indicator of when the membrane has reached its end of life. Rather than relying on just volume and time predictions, performance can be measured and assessed by the slip concentration. Water and chemical washing similarly benefit from efficiency monitoring, allowing control of flow rates for both the gas and the liquids, as well as the slip accounting. It should be noted that amine washing has very minimal methane slip, making that more challenging to measure. PSA methods tend to use less energy but have more methane slip. This often calls for destroying that methane with a regenerative thermal oxidizer, or RTO. Where slip measurement has value is both in the accounting for that methane amount, as well as making sure that too high methane concentrations are not sent to that RTO, which can overheat. Real-time measurement of the RTO feed can prevent damage and shutdowns. Next. And looking closer at the membrane separation, you'll see here again an oversimplified flow of a three-stage membrane system, which is the more common configuration we see. It shows the three common measurement points in a fully instrumented system, the inlet, off gas, and the product gas. Essentially, there are three membrane assemblies that the gas is cascaded through, where the second stage off gas and the third stage product gas are recirculated back into the first stage. This is designed to both increase the purity of the product gas and to minimize the methane slip. What we advocate for here is using the off-gas measurement as an indicator to optimize that recirculation rate for both volume and purity. Because if you recirculate a lot, you'll certainly have a higher purity, but that requires more energy at the compressor and reduces the total volume of the product produced. So from a process standpoint, shooting for about a 98% range seems to work best to manage all the variables. Next. Now, I've discussed using this measurement from a process control and reporting standpoint, but what it really represents is lost production. There's always going to be a trade-off between the purity of the methane product produced and the energy and throughput of the system. So measuring this accurately can help make those decisions, but often this slipstream is not measured very accurately. Frequently, we see the stream measured with instruments responsible for measuring at other locations, using sensors that are measuring full scale and therefore are only between 1% and 5% accurate, where the actual fluctuations in the stream are much smaller than that. So these concentrations are not always reliably accounted for. More accurate alternatives typically come with a much higher cost, but we do hope to change that. And off-gas measurement is only going to become more important as methane slip volumes come under more scrutiny. Carbon credits in their many forms are having their reporting requirements tightened, and we'll be seeing continued focus on more complete carbon accounting from the biogas and RNG operations in the near future. I mean, we're already seeing tighter measurement requirements, and we can certainly expect more to be coming. Next. But burning methane as fuel for electricity and heat generation has been commonplace and an effective way to use this gas in a relatively simple way. But it's not without its challenges, for which gas measurement can be a remedy for. These engines need certain concentrations of methane to both start and run efficiently, and fluctuations in the digester and gas treatment can put that in jeopardy. Ideally, they'd be run continually at a high rate to create the most value. So consistency is best, but adjusting for gas quality variations through measurement is going to work well too. But ultimately, rule number one is don't damage the engine. And the primary causes of engine damage are too low methane concentrations, moisture, hydrogen sulfide, siloxanes, all of which can lead to shutdowns, more frequent service, or voided warranties. Therefore, it's important to make sure that the engine fuel meets spec before combustion to maintain uptime and tune the engine for optimal output. Next, please. And landfill gas is another staple source of methane for CHP and RNG production, but the composition of that gas presents its own unique challenges. Varying qualities and impurities often require complex treatment options or more complex treatment options that need to be consistently monitored to reduce risk and maintain throughput. We commonly see initial measurement at the point where multiple well feeds are combined, which is due to the expensive nature of monitoring. Individual wells are often only checked manually with portable devices rather than with fixed instruments. We'd like to see more incoming measurements to divert certain streams to different uses, but of course my opinion is a little bit biased towards selling more instruments. There are more than enough operators who already balance their feeds effectively, of course, but regardless of measurement, poor quality gas is still diverted to the flare rather than going through the complete treatment process. And that also needs to be measured and accounted for. Next, please. And speaking of flaring, accounting for the methane destroyed is an important aspect to assessing the plant's overall efficiency, as well as for compliance. Whether the gas from the digester or landfill is of poor quality, production exceeds upgrading capacity, or the needs of the boiler or CHP, the remainder is diverted to the flare and needs to be accounted for. A complete picture of the methane product at the site is required. The methane produced at the site is required, and measuring what is sent to the flare is an important part of that. As flare operation can be intermittent, measurement can be a challenge when the gas is hot and saturated, condensing heavily when sent through the flare line. For this application, we recommend measuring upstream before the diverter, where the concentrations will be the same, but there's less condensation actually happening. Next, please. Which brings me to the next topic, which are more of the challenges to making some of these measurements. From high moisture content, hydrogen sulfide, siloxanes, high temperatures and pressures, it can be a lot to ask of the sensor technologies on the market to keep up with. And there can be a lot of components involved to protect traditional instrumentation. Next, please. And as I'm sure you're aware, measurements in biogas and RNG processes are not easy, and between the high humidity and contaminants in the system, it requires specialty hardware and sample conditioning to make sure a gas chromatograph or an extractive analyzer can measure with any reliability. This means drying the gas before measurement, which involves equipment that needs service and replacement parts. Alternatively, some sample lines will need heat tracing to limit condensation and clogging or freezing. This requires additional components and electricity while being susceptible to leaks or the occasional valve that's open when it's not supposed to be. Drying also means that these instruments are reporting gas values on a dry basis rather than the wet basis. And what that means simply is that when you remove the water vapor from the sample stream, the remaining gas concentrations are going to appear higher as the water vapor that was in the gas phase was removed. So unaccounted for, this is going to skew the measurements a little higher, making it seem like there's more methane in that part of the process than there actually is. Correction factors are often applied to account for this, but without actual accurate measurement, it's really just an educated guess. Next, please. A bit more detail about extractive analyzers here, highlighting some of the key components of traditional systems, as these analyzers are not really equipped to measure hot and wet gases. They're going to involve a sample pump, stainless sample lines, moisture traps, and sometimes connected bottles of calibration gas to maintain accuracy. It's quite the assembly to maintain for getting the gas to the sensor bank. This can pose challenges in cold climates where the condensate can freeze and clog lines, requiring heated enclosures and heated lines, like I mentioned. The separate enclosure requirements are also due to the fact that these analyzers are not EX certified for the Class 1 Div 2 or ATEX Zone 0-1 environments at many plants. Additionally, the types of sensors used in these systems and in GCs require frequent calibration, typically ranging from daily to quarterly. There are also some that rely on fresh air to perform periodic zero calibrations, but they don't account for seasonal changes in ambient air, drift from other internal sensor components, or the enclosure they might be in. So with all of that, it's common to see a looser accuracy and stability specification from some of these options. Next. But with all my talk about moisture issues, it's time that I bring up actually measuring humidity, which in itself is not a common measurement in biogas systems. And the reason it's not common is because of the difficulty of performing that measurement. H2S and high humidity is going to foul any traditional humidity chip sensor. And that includes any of Vaisala's industry-leading, highest performance polymer sensors with their chemical purge and self-heating functions. They're simply going to become corroded in raw biogas streams. The other option out there is a tunable diode laser. While they do serve their purposes and they're commonplace in the industry, they are exceptionally expensive and best suited to the lower end of the measurement range. So looking back at this ecosystem illustration, we can see a number of areas where humidity would be a benefit, humidity measurement would be a benefit. So I'll get into a few of those now. Next, please. Heat exchangers are one of the most common ways to knock out the bulk of water vapor from the digester output. They work well for the task and function reliably without much effort, but they do consume a lot of energy. As described here, the temperature of the gas is lowered, essentially making the gas dew point the same as the cooler temperature, causing the majority of the water that the gas was holding to drop out as condensation. But that requires the gas to reach equilibrium, which typically takes longer than the time the gas really stays in the cooler. So what results is an actual dew point temperature that is higher than the target. And the only way to verify that the cooler is working as intended is with a downstream measurement. And higher than intended moisture content can cause a variety of downstream issues. Alternatively, overcorrection or overdrying can waste energy by cooling the gas too much and dropping the dew point below target, which can also create some issues beyond energy waste. Next, please. A prime example of this is with the carbon filters used for H2S removal, which function optimally within a range of 50 to 70% RH, or at a dew point about 10 to 20 degrees Fahrenheit below the gas temperature. One of our European partners, Unegatech, provided these test results for their filters and have begun recommending dew point measurement to their customers for these reasons. Too high humidity could damage the filter if it's allowed to condense and saturate, and too low will significantly decrease the effectiveness. And given the critical step of H2S removal, it's important that this part of the process is protected. Next. That's especially given the high price of these filters, the time and effort to change them out, and the potential downstream effects of contaminants to the engines and upgrading equipment. So the value of this measurement is higher than just the optimized efficiency, and in terms of risk management, we feel that the investment is justified. Next, please. Coming back to the CHP example, high humidity and condensation can cause some very expensive service and outages. Speaking with some of our customers, we've gotten some of the estimates that you see here. Being able to detect water carry through from upstream and address it before the humidity reaches the engine can save many dollars and hours, and even the engine's warranty. Some engine manufacturers specify humidity limits for their engines, and without any way to measure it, you could be risking service life and manufacturer support. Next, please. Similar to engines and carbon filters, the membranes for separation will also be damaged if condensation makes its way into the cluster of tiny gas-permeable hollow filaments. The cause of most condensation that makes its way into the membrane is through the compression of the gas, which effectively increases the dew point temperature. As the average pressures for membrane inlets are somewhere between 120 and 200 psi, that can increase the dew point almost tenfold, as you'll see in the example here, which is above the membrane's operating temperature. This would cause condensation, forcing water into the filaments, clogging them, and reducing throughput. So measuring the dew point before compression can help protect against this type of failure and could negate the need for a separate drying membrane in the system, maybe. Of course, this all goes back to the control of the dehydration system, which is where most of this can be managed. Next, please. Now that leads me to what Vaisala brings to the table to help deliver on some of these efficiencies. And so I'd like to introduce our MGP 260 series of multi-gas probes for biogas, RNG upgrading, and carbon capture applications. I won't be getting into the carbon capture uses here, but I'd be happy to connect with anybody offline. Next, please. The MGP 260 series currently consists of 2 probe models with others in development. The MGP 261 is our full-featured model with full range measurements of methane, carbon dioxide, and water vapor. It has a plus or minus 1% accuracy for the methane and CO2 at typical digester output levels, and a plus or minus 0.5% by volume water vapor accuracy, which is about 3 degrees Fahrenheit or 2 degrees Celsius of dew point accuracy. This model is primarily designed for digester monitoring, but can be used to monitor after the heat exchanger, before the carbon filters, or before compression. We also have customers using them to monitor before the flare line diverters. Now, the MGP 262 model was designed for tail gas measurement, providing full range CO2 and a highly accurate low-level methane measurement with a 0.1% accuracy for 2% and below of methane. The default scale is a 0 to 5% for methane, but that scale can be expanded either at our factory or in the field, and it will still provide a high accuracy of plus or minus 5% of the reading and not the full scale. And now some of you may be wondering about H2S or oxygen measurement, but we don't offer those products at this time. But while we don't sell anything for them ourselves, we can help with some recommendations. Next, please. But besides being the only in-situ moisture measurement for saturated biogas that is hydrogen sulfide compatible, we've also made sure that it's safe to use in EX-rated environments without having to resort to minimum distances from the process or remote enclosures. The 1.5-inch NPT threaded probe body installs directly into the pipe or through a 2-inch ball valve and has the electronics sealed and isolated from the process. With no moving parts or consumables, the IP66 rated probes are designed to be installed outdoors and in a variety of locations. We do not have a real maximum pipe diameter spec, but in situ installations could be done in as small as a 2-inch pipe with the right standoffs. Both probes communicate via 3 4 to 20 milliamp loop powered outputs or Modbus RTU connection. Both options are standard, as well as a powered 4 to 20 milliamp input for a pressure sensor. This pressure sensor would be used for accuracy compensation, but a fixed value can be used for simplicity also. Next, please. The way they work is with our patented CarboCap non-dispersive infrared sensors, or NDIR, which are an evolution of the NDIR sensors that you might be familiar with. What sets these apart are a few key components that deliver more long-term stability than any other NDIR sensor on the market. First, we use our own solid-state light source that does not dim in the way others do, which has a lifespan of over 10 years. And that's compared to a 1 to 3 lifespan of others. The next is the detector itself, which is a mini spectrometer that shifts between a measurement wavelength and a non-measurement wavelength. What that means for you is that our sensors perform a true zero calibration every 7 seconds without the need to try to introduce fresh air to the sensor. These features, along with the sapphire glass cuvette, shields the detector from contamination and condensation and contributes to an annual calibration recommendation rather than a daily, monthly, or quarterly for other instruments. Next, please. And despite having no sampling systems, we do have a couple of accessories available, such as a graphical display with data logger and multiple other communication options. We also have a flow-through adapter. This does allow you to mount the probes remotely if you'd like, and it's just a simple stainless sample cell with an inlet and an outlet. This can be used for field calibration or adjustment, with our USB service cable and free Insight PC software as the interface. Next, please. Taking a quick look at the software, it provides an intuitive interface for viewing the outputs, troubleshooting, changing the configuration settings, or field calibration. You're able to edit the analog output scale, measurement settings, the ranges, signal and error limits, and customize the Modbus registers. And you can do any of this without fear of getting something wrong, since you can always revert back to the factory settings. The probes also store their own factory calibration information, as well as any errors and a history of exposure to extreme conditions. Our free tech support team can use this information to help quickly diagnose pretty much any issue you might have. Next, please. See, typical installation for these is pretty simple. Outside in the pipe, wherever you'd like to measure. It's pretty straightforward, like I said, but there are a few things to consider. Given that this is an optical measurement, they are sensitive to temperature and pressure, so there's a fairly limited range for both, so we can deliver the accuracy that we promise. Anywhere below 140 degrees Fahrenheit and 7.5 PSIG is where we're going to perform best. And they also work under vacuum to about 7.5 PSIG as well. Continuous flow and a horizontal orientation is going to be the best way to manage any condensation in that location of the process as well. Next, please. For the best response times from these units, which is, by the way, 90 seconds in still air and about 30 seconds in consistent flow, we want to have the sensor head directly in the flow and in a low turbulence area. Now, that said, we'll still be able to measure accurately if set back with the ball valve, but the response time may suffer a bit. The other consideration I'd like to say more about is the pressure compensation. For best accuracy and in varying pressures, we recommend a third-party pressure sensor be installed with the probe. Either MGP260 will power the sensor, so no additional power supply would be needed. For most customers, however, setting a fixed pressure into the probe with our Insight software is sufficient. And in constant pressure, it's still very accurate. Next, please. So where this is all going is that we believe certain key measurements made in certain locations are going to lower your overall cost for monitoring, as well as your total operating expenses. This extends to how those measurements are made, although we acknowledge that our solutions are not going to fit every system or measure every parameter that everyone needs. That said, there are some methods out there that are in use that are probably overkill as well. Next, please. Taking a quick look at some of the cost drivers for monitoring, I think we can agree that these are all fairly commonplace. Gas analysis is not exactly cheap, regardless of the options chosen. And in biogas and RNG, there are many points that require measurement for control and compliance. And then there's the upkeep and the folks who are responsible for it. As more projects are developed and become operational, the workforce is going to have to grow, which will then face the pressure to automate, which itself has its pros and cons. Ultimately, you want to minimize the mundane while being able to trust enough to walk away for a while. Next, please. Where the Vysela products compete is both in the upfront and long-term costs. And looking at what's currently on the market, we feel like we can have an impact. Now, these are ballpark figures, of course, and not all conventional analyzers need sampling pumps. But the total componentry and potential for vendor commissioning does add up fast. And we feel that smaller operations can benefit from using a simpler device like ours. Also, when certain systems cost multiples of what ours do, we like to think that more locations can be monitored for less cost with the accuracy that each measurement location needs. Next. Where we have a clearer advantage is in the OpEx arena, as well as in risk management. From requiring less maintenance and calibration effort, which makes automation easier, protecting other capital equipment from damage and loss can be exceptionally valuable. We hope that humidity measurement will become more widely adopted so that more plants can benefit from the efficiencies it promotes. And as cliche as it sounds, we've been leaders in challenging humidity measurements for decades. It's not just because we make sensors, it's because we adapt them to add value to difficult processes. Next, please. And to summarize, we at Visolith feel like our instruments represent a viable option for instrumentation as we approach biogas and RNG monitoring in a unique way. With our reputation for accuracy and stability, we aim to provide you with gas analyzers that will help you have tighter controls over your process, which will make your plants more energy efficient with reliable production. And the better your operations run, the easier it's going to be to develop this industry as a whole, which in turn benefits us all. Next, please. And with that, I'd like to thank you all for your time and attention. I'll now turn it back to Patrick and we can get into some Q&A.
Great, thank you so much, Justin, and great presentation. Good to have an overview of all your product offerings. We have a few questions in here, so we'll take those, and then if any of you have other questions, please go ahead and add them in the questions pod here, and we'll take those as well. First of all, can you give us a sense of the expected lifespan for your probes?
Oh, certainly. So the official response is, 10 plus years. We base that lifespan on the sensors themselves, and if some people are familiar with NDIRs, they tend to burn out over time. We've launched our latest generation that uses that solid state light source that I mentioned, and we have a 10 plus year lifespan on that. And we're not exactly sure how long that's going to last. It could be 15, could be a bit more. I don't think we've really killed them yet. So with calibration over time to account for any drift in that light source, we should be able to stay very accurate for a very long time.
Okay, great. And actually, this one relates to that as well. So regarding maintenance of your products, does Visolith offer that kind of service, service in the field, commissioning to get things going, or calibration of your instruments?
So we don't offer field service, as these are pretty straightforward. You wire them up, you install them, they come calibrated, they're ready to go. Make sure you set whatever pressure compensation you want to use, and into the pipe it goes. We have free tech support. Field calibration is detailed in the manual, but you can send it to us for calibration. We do have in-house calibration if you wanted a traceable calibration certificate for that. But yeah, they're so simple, it doesn't really warrant field service people.
Okay, great. Question here about your mention of contamination. I was hoping to hear a little bit more about contamination, siloxanes specifically. Can you speak about that at all?
Sure. So regarding our probes, anyhow, they come with a sintered Teflon filter that filters out particulates from coming into the measurement area. Now that said, it is semi-solid, so it can get coated. If the gas stream is exceptionally laden with a lot of these particulates that are coating things, it would be in your best interest to perhaps choose a ball valve installation so you can take it out and clean it. The filters are easily removed and cleaned and then reinstalled. The sensor whole cuvette itself can also be cleaned and put back in. So it can only measure what it can see. So if you blind it by coating it with things, then it's going to need a little bit more maintenance than perhaps just calibration. But otherwise, as long as it doesn't get covered in there, it's going to be fine.
This question is a little bit more about the marketplace, especially for membrane systems. Are you aware of how much market share membrane systems have, and if so, where do those facilities tend to be, or like what types of projects are mostly using membrane systems?
Well, it's mostly upgrading for RNG for either transport and ultimately the pipeline injection. I wouldn't be able to give you a number itself. I do know that it's majority. That could be just more than the others, or a straight majority. But yeah, I'm sorry, I wouldn't be the authority in that particular market share answer.
Okay. We're getting a couple here related a little bit more to maintenance and calibration. So can you estimate an annual cost for calibration? Is that something you're willing to do, or is that something that people should contact you individually for?
Oh, sure. I can ballpark what it would cost for us. We are currently charging, I think it's between 900 and 1,000. I think it's maybe 920 something dollars here, and this is August 29th, 2023. So this is being watched later. That's what we charge. It comes with a traceable calibration certificate, and it comes with return shipping. But if you're calibrating in the field, you can do that yourself with locally sourced calibration gases. The likelihood that a lot of these facilities are using calibration gases for other instrumentation is pretty high, and so you can either use what you're purchasing for somebody else, or if you wanted to purchase your own mix. We do have some guidelines in the manual, but they're loose, so you can really use whatever is appropriate for your application. And we do sell that flow-through chamber. It's currently just shy of $500, but it really is just an inlet and an outlet, and you could make something yourself if you wanted to.
How about tech support? Is that something that's available 24/7 or just normal work time hours, or what time's
normal
up?
work time hours. We're based here in the U.S., and so not exactly banker's hours, but you can pretty much expect to reach somebody anytime between 8 a.m. and 6 p.m. East Coast time. And then I'm available as well pretty much all the time. So we're a small team here.
Just like a good sales guy.
Yeah, trying.
Talk about replacement parts. What do you recommend for those? And could you give an annual cost to replacement parts that you recommend having on hand?
Well, the only replaceable user replaceable part there is that sintered Teflon filter. And in clean gas streams, you're not going to have to replace it. If it's really dirty, or you're spraying different oils or things like that into the process, you may want to keep a couple on hand just so you can rotate them out. But that's about it.
Great. And I think our last question here. Can you compare the products that you offer to a typical gas chromatograph in terms of what you cover and the gas chromatograph does?
So, I mean, there's a good amount to unpack in that one, because we're not going to measure all the parameters that a gas chromatograph is going to offer. Depending on how the unit is calibrated, what type of column is in there, we can either match or exceed those accuracy specifications, or we could fall short depending on what part of the process they're measuring. But that said, where we really come up against them is with the sampling systems required. GCs are very sensitive to particulates and moisture and other contaminants, so we're pretty robust in that regard. For the most part, when it all said and done, between sampling pumps, calibration gases, tubing, and all that stuff, we're still a fraction of the cost of one of those. So it depends on where you are in the process, what type of accuracy you need. But again, there's a lot of different variations in there. We're not a one-to-one for sure, but we do feel like we can displace some GCs for some locations.
All right, and last question, what's the lead time for your products currently?
4 weeks, which is probably leading the industry in delivering analyzers at this point in time. We hope to have that shortened up a little bit, but at the same time, we hope to have more volume that kind of stays at 4 weeks. So, 4 weeks from the day we enter the order until it's delivered. So we also ship everything free 2-day DHL. DHL usually delivers in 3 days, but that's all factored into that 4 weeks.
Great. All right. Well, Justin, thank you so much. Caroline, I'm going to turn it back over to you to close this out here. And yeah, appreciate everyone's time and attention.
Yeah. Thank you, Patrick.
Thanks, Patrick. Thanks, Justin. Just a reminder, we do have a survey that pops up at the end of this webinar. Please take a few minutes to fill that out. Also, please consider becoming a member of the American Biogas Council. You can learn more about our membership on our website, americanbiogascouncil.org. And we hope to see you at Business of Biogas in October. You can find out more about that at americanbiogascouncil.org/BOB. Thanks, everyone, for attending, and we'll see you on the next one. Bye.
Bye, everybody.